Now that we've talked about the motivation for the state pattern in the context of the expression tree processing app, let's take a step back and talk about this from the point of view of the structure and functionality of the pattern, as you might find in the Gang of Four book. So the intent of this pattern is to allow an object to alter its behavior whenever its internal state changes. So key to this is the whole concept of keeping track of the state that you're in. And what this does is it allows the object to give the appearance of changing its class without changing its API. What does it mean to change its class? What it means is that the same methods called in a different state will behave differently. Sometimes they'll do something sensible. Sometimes they'll throw an exception. Sometimes they'll do something else. It all depends on whatever state the object happens to be in at the point when the method's called. You should consider applying this pattern when an object must change its behavior at runtime depending on what state it's currently in. And you could also think about this when you have several operations that would normally share the same large multi-part conditional structure that depends on the object's state. And we're going to see some nice examples of this as we look into the implementation in a bit more detail in the next video. So here's the overall structure and participants of the pattern. You'll see at first glance it looks a bit suspiciously similar to other patterns we've looked at. Most notably, it looks quite a bit like strategy. It looks quite a bit like bridge. And we'll talk about that because this is always the tricky part with the Gang of Four diagrams. You have to look at more than just the diagrams in order to be able to successfully deconflict what these patterns are trying to do. So here we've got the state class, which is an abstract base class, which defines multiple methods. We have concrete state classes, which obviously inherit from the state superclass or abstract base class. And this would include things like uninitialized state, pre-order uninitialized state, pre-order initialized state, and so on and so forth. And then we have the tree context, which in the pattern is just called context, and we use it to manage the interface to the tree. And this is the part that's actually visible to the client, to the application program that's using the state pattern. And so clients will invoke requests by making method calls via the context object. And you can see what happens here is when you invoke a request on the context, then it turns around and invokes the corresponding method on whatever state happens to be configured at the moment, passing the context in as the first parameter, thereby engaging in this so-called delegation mechanism, which is just a fancier way of doing forwarding. Now, again, this looks very much like some other Gang of Four patterns. It looks an awful lot like strategy. It's even got a context, right? So both strategy and state have context. Both strategy and state have abstract base classes. Both strategy and state have subclasses that derive from those abstract base classes, and so on and so forth. The main ways in which it differs is, number one, you always invoke the methods through the context with state, whereas if you recall, you don't invoke methods through the context in strategy. It's just there as a kind of a blackboard to share information between different concrete strategies in the strategy pattern. So that's one difference. And the other difference is that the internal implementation in the state hierarchy for the state pattern can change between invocations, whereas in strategy, you typically configure it and it stays there. And so it doesn't change on a per invocation basis because strategy is not trying to keep track of state the way that state is. So you can also think in a sense that the context in the state pattern is a bit like the abstraction role in the bridge pattern. It's the way that the clients invoke operations on the object. And then the object will keep track using this delegation technique between the context and the state hierarchy to update the state, which then is used to modify what context is available to the client next time they make an operation call. And we'll see how that gets applied here shortly when we take a look at the implementation in C++.